Hello, this is the first module for Energy 101, and what we'll focus on in this module is energy and society, because our society is the driver for the energy that we have to use. If we back up and take a real big picture look at energy flow in society, we see that we as a society want energy, and we'll get into exactly what that means here in a few minutes. But we can't create that energy out of nothing. We have to get it from a natural energy resource that occurs naturally on the earth. But then we have to use energy conversion technologies and a massive infrastructure in order to provide the energy that society uses. So the energy used by society is the driver. That's the tail that wags the entire dog of energy. It's what has created all of the opportunities and all of the cost and the environmental impact that is due to energy today. So let's focus on the tail that wags the dog, how society uses energy and why we use it and why we want it. Okay. So we're seeing why society wants energy, and we split it into the three major sectors: building, comfort, manufacturing goods, and transportation. And that's the tail that wags the dog that creates the need for all the backup that's required to supply that energy to that society. Well, how much does each one of these sectors use? Well, it's fairly equal if you look at this pie chart. We see that the largest consumer of our energy in the U.S. is buildings, the residences, our homes, the shops, the office buildings. That consumes about 41% of the total energy consumed in this country. 41%. A little more than a third, less than half. 41%. The next largest user of energy in our country is manufacturing cars, manufacturing goods. That uses approximately a third again, 31%. That's the red sector. And the third sector, transportation, is 28%. Again, about 5% less than a third. So you can roughly say that they're split about a third and a third and a third, with buildings being a little more, transportation being a little less. So let's dive a little deeper now into what we mean by buildings use energy. What kind of energy does buildings need? What kind of energy does manufacturing need? What kind of energy does transportation need? Because there are different forms of energy that we like to have and we want to use as we go about our daily lives and a society that's built on hundreds of years of utilizing energy. Well, one category of energy that all of these sectors use is heat. Building comfort. We don't like for it to be 20 degrees inside our house when it's 20 degrees outside. So we want to heat the indoor air. That takes energy to do that. We also don't like it being 95 degrees inside when it's 95 degrees outside. I happen to grow up in South Florida before the advent of massive air conditioning. So I know what it's like to live in a hot climate without air conditioning. But that's not the norm today. We like to be cool. We've gotten so adapted to it, as a matter of fact, we really aren't adjusted to very much hot weather. Manufacturing, we'd have to heat things up to manufacture them. Steel, when you manufacture steel, uses a lot of energy. You've got to melt the steel. Glass, uses a lot of energy, as you might imagine. Another big need for energy in the manufacturing sector are things like drying carpets. When you make carpet and you dye it, then you have to dry it. Drying is a very large energy consumer in manufacturing processes, and it's one that we're trying to improve the technology on in order to reduce the amount of energy required to dry products during the manufacturing process. Obviously cooking, we don't think much about it, we just take it for granted. But that was one of the earliest uses for energy. The caveman started cooking his food. He didn't used to do that. He used to burn wood in order to cook energy. Wood is biomass. We see that biomass is one of the big renewable energies that we actually use today later on. Hot water. We don't like cold showers. We like hot water. We want to wash our clothes in hot water. We want to wash dishes in hot water. So we need a lot of heat in all of these sectors. What about work? Work is a form that we need. Things like pushing a car. You know that it takes a lot of work if your car stalls and you have to push it out of the middle of the intersection. Some people generally have to help you. You have to push with a pretty good force in order to roll the car forward, even at a very slow speed. So when you push on something with a force and move it through a distance, that is the basic definition of work. So transportation, to push all our cars around, to push the airplanes around, the trains around, requires a lot of work. That is the form of energy that we use a lot of. Pumping water. Well, how does pumping water use work? Well, it takes work to rotate a shaft. Rotating a shaft with a torque is a basic definition of work. And when you turn the tap on in your house or turn the shower head on to get water, you don't realize how much energy is being used back at the water plant to pump the water from a lake or from a deep well, bring it up to pressure that can push it through the network of pipes throughout the city or the countryside in order to get it to your faucet and your shower head. So pumping water is one of the largest energy users. In fact, it's generally the largest energy bill that a municipality has, is paying the electric bill to drive the water pumps to pump water around their city. Appliances, the clothes washers, for instance, they have to have the agitator that goes back and forth. All of our appliances, be it a blender, be it a clothes washer, most appliances use some form of work. So that's another category of work, sliced in a different way than the transportation, buildings, and manufacturing sector. As we move through the different types of energy that we use in these sectors, there's quite a bit of energy used in the materials, in manufacturing materials. We're not talking about melting steel or things. We're talking about manufacturing things that actually need the molecule of the hydrocarbon that comes in natural gas, coal, and oil in particular. You need that molecule to make plastics. You need it to make chemicals, all kinds that we use in other manufacturing processes. Fertilizer is one we don't think about as being a big energy user, but fertilizer that allows us to grow a lot more corn on an acre and requires a lot less manpower, because we fertilize it and get twice as much corn production by tilling the same amount of ground, has allowed a lot of us to move off the farm, which I grew up on, and move into an office building somewhere overlooking the city and leave fewer people back on the farm raising the food that we need for survival. Fertilizer is a big user of energy, just the molecule itself. We don't burn it, but we actually use the molecule. Cooling, already mentioned space conditioning. Air conditioning and refrigeration, they're both cooling. It's really just two different applications of cooling, but it takes energy to drive the air conditioner. It takes energy to drive the refrigerator. Refrigeration was one of the first users of energy in a civilized society. Before refrigeration, we had to go to the shop and buy our food every day, because if you bought it 2 or 3 days in advance, it would be spoiled by the time we got ready to use it. So you went and bought your food every day for it to be eaten that night or the next day at the least. So with the advent of refrigeration, that meant that we could go to the store once a week and buy the groceries that we need and put it in the freezer and put it in the refrigerator, and it would be preserved. Lighting. Lighting is a big user of electricity and energy. Home and office, of course, and we want in order to be able to work and read in the home and office, you need lights. We have highway lights. Security lighting is, we're adding more and more light in our cities, in particular for security purposes. Fortunately, lighting technologies such as LEDs are reducing the amount of energy we use to provide the same amount of light. It's a huge advancement in the efficiency of lighting. That's going to help us a lot in reducing our energy consumption for lighting. But lighting is a significant one in that building heat, building comfort area, and that we see that uses a little more than a third of our energy in the U.S. sectors. Then the next module will continue looking at energy and society from the energy and economy, how the economy and energy is linked. Thank you.